Okay, let's look at these problems. So on these first three, we wanted to simplify these radical expressions. That means we want to be thinking, first of all, just look at the number and think, is 54 a perfect square? Can you take the square root of 54? No, 54 is not a perfect square. So now you need to think, can I simplify it by taking out perfect square factors? Remember, perfect square factors are 1 squared, 2 squared, 3 squared, 4 squared, and so on, which would be 1, 4, 9, 16. So these numbers here are the perfect squares, and we want to be thinking, all right, are any of these numbers a factor of 54? Well, we notice 9 is a factor of 54, so we can rewrite 54 as the square root of 9 times the square root of 6. And now we've got the factor of radical 9 taken out. Well, the square root of 9 is 3. So there's our answer, 3 radical 6, or 3 times the square root of 6. You took out the square root of 9, and you were able to simplify that part. On 24, two ways to think about this. You can always, first of all, try to simplify the fraction. And so, if you think about 144 over 36, 144 over 36 is 4. So that fraction simplifies to 4, and then you could think of it as square root of 4, which is 2. Another way to think about this, since this is a quotient, you can break that up into two separate parts, and you can think of that as the square root of 144 over the square root of 36, and then simplify each of those. The square root of 144 is 12, square root of 6, square root of 36 is 6, and that also gives you 2. So either way, it gives you the answer of 2. 25. 48 is not a perfect square, but think about what the factors of 48 are. Again, you want to think perfect square factors. Say, all right, 2 squared is 4, so 4 is a perfect square. That's a factor of 48. So you could definitely do that, but is that the most simplified? Think about the other factors of 48. Are there any greater factors? Well, 3 squared is 9. 9's not a factor of 48. What's the next perfect square? 4 squared is 16. 16 is a factor of 48, so we can rewrite 48 as the square root of 16 times the square root of 3. 16 times 3 is 48, so that leaves us with 4 times the square root of 3. So there's our simplified answer for that. If you would have done 4 times 12, and then that would have given you 2 radical 12, right? But remember, 12 has a factor of 4, so you could have factored out 4 again and made it 2 times radical 4 times radical 3, and then square root of 4 is 2, 2 times 2 is 4. That takes you to the same 4 radical 3. So make sure you're taking out the greatest common factor. 26, you're solving these. So you don't have anything outside the parentheses. This expression is squared, so since x is inside the parentheses, you want to undo that square so you can then isolate the x. So if you take the square root of both sides, that's going to leave you with x plus 8 on this side, and on the other side, it's going to be the positive or negative square root of 26. So then you would need to get the x by itself by subtracting 8. So you can say x equals, actually I like to break this up first of all, because you've got two different possible answers, a positive or a negative. So I'm going to say, all right, x plus 8 can be equal to the positive square root of 26, or x plus 8 can be equal to the negative square root of 26. And then at this point, I'm going to solve the two separate equations. I just need to subtract 8 from both sides. So if I subtract 8 from both sides, that leaves us with square root of 26 minus 8. And the other would be x is equal to negative square root of 26 minus the 8. So those are our two different answers. Alright? What about 27? I can solve this by, I want to get the x squared by itself. So first of all, I want to get rid of the coefficient, so divide both sides by 4. And that leaves us with x squared. 100 divided by 4 is 25. So now to simplify this, I want to take the square root of both sides to get rid of the exponent. So x is going to be the positive or negative square root of 25. Positive square root of 25, negative square root of 25. X is equal to 5 or negative 5. You can also write it as x equals positive or negative 5. You'll see it written either way. Either way you write it, that means x can be two different values. Got 28. 5n squared, n is right here. So we want to first of all isolate this variable term by moving the 9 over to the other side. So that leaves you with 5n squared. Over here, 89 minus 9 is 80. Now to get the n squared by itself, we can divide both sides by 5. And we get n squared equals 16. At this point, if n squared is 16, that means n is equal to the positive or negative square root of 16, which is 4. So that means n can be positive or negative 4. You can write it like that, or you can say n equals 4 or negative 4. That way or that way. And then just quickly, remember, you can always check these to make sure you're right. So if n is 4, if you go back here, 4 to the second power is 16, 16 times 5 is 80, and then 80 plus 9 gives you the 89. Or if you want to test the negative 4, that would mean 5, and remember, you've got to be careful with your signs here. N squared would mean negative 4 squared plus 9. Negative 4 times negative 4 is 16. 5 times 16 plus 9 gives you 89. Alright? And on 29, our variable is here, so we want to undo the plus 10, so subtract 10 from both sides. That leaves us with a minus 6 squared equals 100. At this point, we can undo the exponent of 2 by taking the square root of both sides. Well, the square root of this will leave you with a minus 6, and over here we can then take the positive or negative square root of 100, which is going to be 10. So I can say a minus 6 equals positive 10, because the positive square root of 100 is 10, or a minus 6 is equal to negative 10. Now we need to add 6 to both sides. 10 plus 6 is 16, so a can be 16, or add 6 to both sides. A can be negative 10 plus 6 equals negative 4. So those would be the two values of a that would make this equation true. And again, to quickly check it, if a is 16, replace a with 16. 16 minus 6 is 10. 10 squared is 100. 100 plus 10 equals 110. So that works. What about for negative 4? Negative 4 minus 6, that's negative 10. So that would become negative 10 squared plus 10. Well, negative 10 times negative 10 is 100. 100 plus 10 gives you 110. And then on the last one, if you look at this quickly, you might be thinking of this, because this is the way we've seen the problems before. Notice where the exponent is here. It's not outside the parentheses, it's just with the x squared. So pay attention to that. So two different ways you could think about this. You could say, all right, I could distribute the 3. Now if it would have been this, can you distribute the 3 first? No, you've got to do the exponents first. So you could divide by 3 to get rid of the parentheses, but it's not like that. But in this one, the exponent's not outside the parentheses, so you could distribute the 3, and what if I did it that way? I could say, alright, 3x squared, and then distribute it here, plus 21 minus 5 equals 14. Then you can combine the 21 minus 5, you get 3x squared plus 16 equals 14. Subtract 16 from both sides, and you get 3x squared equals negative 2. Divide both sides by 3, and you get x squared equals negative 2/3. You should already be thinking about something right here. Now to solve for x, you've got to take the positive, or you've got to take the square root of both sides. So x can be the positive or negative square root of negative 2/3. What do you notice here? You're taking the square root of a negative number. You can't do that. So that tells us that this equation has no solution. There's no number that would make that true. Let's just quickly look at the other way you could have done this. Rather than distributing the 3 first, you could have added 5 to both sides, and that would leave you with 3 times x squared plus 7 equals 19. Just add 5 to both sides, and then at this point, rather than distributing, you could just undo the times 3 by dividing both sides by 3. So you would have x squared plus 7 equals 19 over 3, and at this point subtract 7 from both sides, and you could have x squared equals 19 over 3 minus 7. You just took away 7 from both sides. Well, 19 over 3, I could change this to a common denominator. 7 is the same as 21 over 3. Now you've got common denominators, and that means x squared equals 19 minus 21, which is negative 2/3. And at this point, you should notice, oops, it matches what you have right here. So then the same thing's going to happen. You're going to get square root of a negative number, which gives you no solution. So those are the examples on how to solve these problems for today. Let me know if you've got a question, all right?